What if you could build an entire universe, not from matter and energy, but from pure numbers? What if a few simple rules of arithmetic could just erupt into this breathtaking complexity all on their own? It might sound a little like science fiction, but today we're going to explore how that can actually happen. So let's dive in.
First, just take a look at this. It really looks like a swirling galaxy, right? Maybe something the Webb telescope spotted deep in space. But what if I told you this image wasn't taken from space at all? What if it was generated just from counting?
This whole exploration really kicks off from a simple but honestly pretty profound idea. It was inspired by a post from a math hobbyist online who just said, "Numbers are particles," a statement that makes you think, what if every number is a fundamental building block of some hidden reality?
Okay, so how do we get from a cool idea like that to the swirling patterns we just saw? Well, we're going to build our own little toy universe right here from the ground up, starting with the most basic building blocks we have, numbers themselves.
The very first step is to turn these abstract things we call numbers into something we can actually see and map out. And the core idea is simple, but it's really powerful. What if we could give every single integer, 1, 2, 3, 4, on and on, its own unique address in space, a specific point where it lives?
Now, to assign these locations, we're going to need a set of instructions, a kind of source code for our universe. And this code, it's built from the most fundamental components of numbers, their prime factors. You can really think of it as the unique DNA for every single number.
So the engine that drives this whole thing is a special function, let's just call it S_n. Think of it like a recipe that creates a unique prime factor signature for any number. The idea is pretty brilliant. You take a number, you break it down into all its prime factors, and for each of those factors, you assign it a specific direction, like an arrow pointing out in space. Then you just add up all those arrows, head to tail, and the final point where you land, that's the number's unique address in our universe. Let's make this real with an example, say the number 12. First, we find its prime DNA, which is 2, 2, and 3. Now we give each of those a direction. That's what these little omega symbols represent. They're just a mathematical way of saying point in this specific direction. Once we have our 3 directional arrows, we just add them up. The point we end up at is the one and only location for the number 12. And it's a surprisingly simple process that we can just repeat for any number we want.
So that's the rule for one number. But what happens when we apply this rule to thousands and thousands and thousands of numbers? Well, this is where the magic really starts to happen. By tweaking just one fundamental parameter, like one single law of our universe, we can reveal entirely different geometries just hiding there in plain sight.
See, at the heart of our universe is this one parameter that defines the fundamental turn or direction for each prime. We'll call it the period. And what's absolutely incredible is what happens when we change it. If we set this period to 10, a stunning structure emerges, and it's intrinsically linked to the golden ratio, phi. But if we change that one number to 6, a completely different pattern appears, one that seems to organize the prime numbers themselves in this very specific, beautiful way.
And this isn't just some vague resemblance. If you actually look at the math for the period 10 universe, the connection is explicit. The coordinates for each number, they aren't just similar to the golden ratio. They are literally calculated using phi. It's baked right into the geometry of the whole system. So the crucial takeaway here is this. The rules we set at the very beginning, the fundamental laws of our numerical universe, they directly sculpt the shape of everything that emerges from it. We're literally turning these hidden mathematical relationships into visible geometric structures.
But, this prime factor method isn't the only way you can build a universe from numbers. Let's explore what happens when we introduce a totally different set of rules and get to see this delicate dance between profound order and, well, total chaos. Okay, so here's a completely different approach. It's called parallel addition. Instead of prime factors, we just start with 2 numbers, and at each step, we replace them with 2 new numbers. Their arithmetic mean, which is just their regular average, and their harmonic mean, which is another type of average. It's this simple, recursive process that just keeps feeding back on itself, over and over again. Now, if we start this process with 2 positive numbers, something really beautiful happens. The system very quickly finds a perfect balance. It just settles down, converging elegantly on the geometric mean of the 2 numbers. It's pure, predictable order.
But, and this is where it gets really amazing, if we make one tiny change to our starting conditions and use 2 numbers with opposite signs, so one positive and one negative,
the entire system just collapses into this unpredictable, beautiful chaos. The exact same rule creates two completely different destinies. That right there is a perfect example of emergent complexity.
But you know, complex systems don't always have to lead to chaos. Let's jump back to our original prime factor universe for just a second. Using a different kind of simple rule, in this case, symmetry, we can also build profound order. Just look at this. This intricate, almost atomic-looking structure, it's not made of hundreds of different lines. It's built from just one of our prime-based curves, which has been reflected symmetrically 48 times. A whole universe of complexity spun from a single thread.
So, we've seen abstract numbers become visible geometry. But the exploration didn't stop there. What if we could take this one giant leap further and actually listen to them?
This is a custom-built MIDI playground, and what you're seeing here is a direct translation of the geometric plots we've been looking at into music. Every dot that represents a number is now a potential note. So we're no longer just looking at the universe of numbers, we're listening to its soundtrack.
It's a pretty mind-bending idea, right? But how does it actually work? How do you take the location of the number 12, or the prime number 13, and turn that into a note you can play on a piano?
The translation is actually surprisingly direct and elegant. So think about our plots. The vertical position, the height of each number's point, gets mapped to one of the 88 keys on a piano. The sequence of the numbers themselves, 1, 2, 3, 4, becomes the rhythm, that steady flow of time. You can even change the tempo, the musical scale, or the instrument. And for a final, brilliant touch, every time a prime number shows up, it can trigger a distinct percussive sound, like a clap or a snare, making the primes literally hit a different beat.
We've journeyed from this simple idea that numbers are particles, all the way to building universes, discovering these hidden geometries, and even composing music from the very essence of prime numbers. It really leaves you with a final, awe-inspiring question. If this is the music of numbers, what other profound patterns and hidden structures are all around us, just waiting for us to find the right way to look or to listen?